Hello, we from Group 2, we present about 3D Dynamics assignment which require us to examine a fan. So my name is Muhammad Danial bin KAMARUDIN. We'll talk about the intro of this assignment. So our objective for the assignment, we need to analyze the speed of the fan blade. We need to analyze the swivel. We need to calculate the angular velocity and also acceleration for both speed settings. And also calculate the resultant velocity and acceleration during the fan swivel. So this is how we estimate the RPM of the fan. We put a sticker on one of the blades. We tilt a little, turn on it on lower speed setting, and then record it for 30 seconds. And then we repeat. We wash back the recording using slow-mo effect. And then we can get the RPM by counting one by one. We repeat this step for higher speed setting. Estimate the swivel of the fan. We place a marker on top of the fan. In this case it is the knob here. We tilt the fan a little and then we record it for 30 seconds. We use Kinovia to calculate the angle of the, and then we repeat this step using higher speed setting. This is our data obtained. So this is our radius of the blade, 19.5 centimeter. This is the length between body and center, which is 16 centimeter. This line. And also the angle of tilt, which is 24. We're using Kinovia to get this data. That's all from me.
After the analysis, we can determine the speed in every 10-second time interval. The average speed of the fan blade is 2.49 meters per second. Next, by dividing average speed by the radius of fan blade, we'll get 12.7692 radian per second for the blade velocity at lower speed setting. To find the swivel velocity, we need to determine the angle of rotation to left and right. The fan turns 0.7958 radian to the left and 0.5323 radian to the right in 4.28 and 3.41 seconds respectively. The swivel velocity to each side can be obtained by change in angular rotation divided by change in time. The final swivel velocity is calculated by sum up the swivel velocity to left and right, then divided by 2, which is 0.171 radian per second. The same steps can be performed to find the blade velocity at the highest speed setting. The average fan blade speed is 3.08 meters per second, and by dividing it with radius, the blade velocity is 15.7959 radian per second. At higher speed setting, the fan turns 0.8116 radian to the left in 3.11 seconds, while it turns 0.5149 radian in 2.35 seconds to the right. The swivel velocity to the left and right is 0.261 radian per second and
Hello, my name is AZRI, KIB3006. So for this assignment, I'll be explaining about how to get the angular velocity of the fan blade and how to get the velocity at the tip of the fan blade. For I start, I will show you some of the information that we get from the previous calculation made by my group blades. And this is the position of the tip of the fan blade from the center of the fan blade, vector of it. And this is the direction of the z-axis. The fan is tilted at the angle of 24 degrees. So for the low speed setting, this is how to find the angular velocity of the tip of the fan blade. The reference, the angular velocity at the z-axis plus the angular velocity at the reference axis. Insert the variable of it and insert the number of it, and we get the answer 0.1562 J plus 12.8388 K rad per second. And the velocity at the tip of the fan blade, we use the cross vector formula. We insert the vector of the at the angular velocity and the vector of the radius of the tip of the fan blade, and we get negative 2.4786 I meter per second. For the highest speed setting, we use the same formula for both calculation. We insert the angular velocity at z-axis plus angular velocity at the reference axis. We set the number of the variable and calculate it, and we got the answer 0.2193 J plus 15.8936 K rad per second. And for the velocity of the at the tip of the fan blade, and we use the cross vector formula, and we get negative 3.0642 I meter per second. That's all from me. Thank you.
Now, using all the variables measured and the calculated angular velocity and the velocity of the tip of the fan blade, we will be able to calculate the angular acceleration and the acceleration of the tip of the fan blade. So firstly, for the lower setting, the angular acceleration of the tip of the fan blade is the cross product of the vector of the reference axis times the angular velocity. This will give us 1.9948 radian per square second in the axis. Next, for the acceleration of the tip of the fan blade, we just need to calculate the summation of the cross product of the angular acceleration times the position vector and the angular velocity times the velocity. This will give us this number. And then for the higher setting, we just need to replace the variables. As you can see here. And same for the acceleration. And the result of our experiment here, at the lower setting, we get the respective number. And for the higher setting, we get the respective number. As you can see, for the higher setting, the velocity and the acceleration of the tip of the fan blade is much higher than the lower setting. That's all from us. Thank you.